a little later. But the real point is that, as I'll talk about in a minute also, there are, as all of us know, there's huge challenges facing the transportation sector. And the question is, what do we do about it? And the tendency of the profession, even of academia, is to look at incremental enhancements. And I'm going to kind of toss out some ideas about real major transformations. I'm going to focus more on the energy and vehicle side of it, but I'm also going to broaden it out to the whole transportation sector. So, as I said, I'm going to focus on fuels and technology to start with, and some information technology in terms of how to make a better and different transportation system. Starting on the energy part of it, these are some books that have been published in the last few years, the titles of them, and they all kind of give the sense that the I guess the informed public, as I say, believes that the end of oil is here, the combustion engine is on its last strokes, and something big is going to happen. And even a few nights ago, George Bush, not known for his grand visions in the energy area or environmentalism, came out with a statement, America is addicted to oil. And what was interesting about that, I listened to this speech, and this is excerpted from it, and it was really just a couple of paragraphs out of a 50-minute speech. It was a tiny part of it, and yet the media, many of the major newspapers, the New York Times and others, AOL on its website, this is the headline that they used to portray the speech. America is addicted to oil, when in fact that was a tiny part of the speech. But anyway, we'll go with it. So, this is what he said, we have to break this addiction through technology, and we need to change our vehicles. And he came up with this thing about switchgrass, and I got a whole bunch of calls from reporters the next day. Switchgrass. It was rather peculiar, delving into that kind of detail, but okay. So, in many ways, though, looking at in the big picture, we have come a long ways. This is transportation, 100 years ago, before, maybe 110 years ago, before motorized vehicles and motorized transportation really became a major part of our transportation and really transformed it. And the result of this is a fascinating graph. This was done by some Europeans, and this is actually for France. But what it is, this is a graph that shows how people have increased the amount of travel that they do, and this is a logarithmic graph on the left, and so this is exponential. I mean, this is strong, large increases in movement of people per capita, since 1800 in this case. And this is for France. But this is a phenomena seen everywhere. This very rapid, dramatic increase in travel. And one of the questions is, will it continue? And if so, how? And part of it is, in developing countries, there's been an explosive growth in personal mobility, personal vehicles. I do a lot of work in China, and these are just some photos of some technology in China. Actually, this vehicle up here, this is actually a mass-produced vehicle in China, $4,000, has anti-lock braking, airbags, power windows, $4,000. Beijing, the city has over 2 million vehicles in it now, when 10 years ago it had hardly any. But I have some kind of funky little vehicles there to show that they're even in the rural areas they're developing some kind of vehicles to serve rural needs. But it all is part of this picture of this mobility that's dramatically increasing. And then I showed they have a maglev train in China just to show you that there is this whole range of technologies that they're bringing to bear. Now, in the United States, bring back the U.S., vehicles, as we know, dominate travel in the U.S. Transit now serves only 2% of passenger miles in the U.S. 60% of households have 2 or more vehicles. we have more than one vehicle per licensed driver. You know, we used to think, what's saturation? Well, one vehicle per licensed driver seems like saturation. Well, we passed that a long time ago. It's up to about 1.14 now, and still increasing. Think about that. And then if you looking at just some of the trends, VMT, vehicle miles traveled, this is over, you know, a period of about 20 years, increased, 2.5 times, or 150 or 160%, much more than population. So the amount of travel, so per capita, we are traveling a lot more than we used to, and we're continuing to increase how much we travel per capita at a faster, so travel is increasing at a faster rate than population. And down there, you see that pink line at the bottom, and that is the lane miles that are being built, and that's barely increasing. And of course, that leads to the question of, well, with all this population increase and all this travel increase and no increase in lane miles, you know, how does this work? And we can come back to that as well. So this was actually a cover story in Los Angeles. I thought. And that was 15 years ago. Here's one way of rethinking the car. This is actually another old. They used to have a lot of more vision in the old days than they do now. This is not the future, but we can talk about. If anyone thinks it is, we can talk about it. And part of this proliferation of vehicles in the U.S. and in the world is this, dramatic, or maybe not dramatic, but continuing increases in oil consumption. And in the United States, we consume something like 14 million barrels per day of oil, and about 2/3 of that is for transportation. And this is, something we're seeing all around the world. And along with that increase in oil consumption is increases in greenhouse gases and CO2. In the United States, about 1/3 of the greenhouse gases comes from transportation, and most of that from vehicles. It's the second largest sector and probably will become the largest in the future. So, so kind of the storyline so far is, to the extent there's an oil problem, it's largely a transportation problem, and to the extent there's a climate change problem, transportation plays a big role in that as well. And of course, the cause of all this is the increasing motor vehicle travel. And I'm not going to get into climate science, but this is just one picture that always kind of stunned me. This just shows how the polar ice cap has been shrinking, and it, here it shows 20%. 20% of it, in terms of spatial dimensions, 20% of it has melted away since 1979. But here's another one of my graphs that I think in some ways might even be the most important graph we can, as human civilization, can be familiar with. This is a graph that shows what's happening. There's the baseline that shows the CO2 emissions in the world. And now this is a long time scale here. So it looks like a steep curve, but it's kind of distorted by the compression of the time scales. But nonetheless, businesses, not even business as usual, what is the likely scenario of CO2 production as a greenhouse gas in the world is a steady increase into the future. And all these other curves are curves that show that if we're going to stabilize CO2 concentrations in the atmosphere at different levels, that's the amount of CO2 that can be emitted. So for instance, if we're going, right now, pre-industrial, it was 275 parts per million CO2 in the atmosphere. Now we're up to about 375. And so the scientists say if you double the concentration from pre-industrial to 550, that's really heading towards Russian roulette. At that point, it's threatening real catastrophe. The science is not, that well established that they can say exactly what's going to happen. But the scientists pretty much say if you double it, you're really asking for trouble. Really bad things might happen. So that's the 550 right there. So what that says is that that curve has to start breaking away from the business as usual case fairly soon. And if you go to 2050, that's about a 1/3 reduction from where the business as usual case is. And by 2100, it's something like a 90% reduction. And that's for a doubling of CO2. And so if you start thinking about transportation in that context, you say, okay, if we're going to get a 30% reduction in CO2 by 2050, or a 90% by 2090, how are we going to do that? There sure isn't any path that we see before us for that to happen. And so it means that there has to be some kind of transformation of our energy system and our transportation system. So now before I get, to get too morbid and, about this whole topic and pessimistic, there is one very important success story for transportation, and that is air pollution. The conventional air pollutants, the criteria air pollutants, have been reduced overall, and dramatically so on a per mile basis for vehicles. And this is just total emissions for the country from light duty vehicles. And for every pollutant, it's gone down. For some of them, it's gone down dramatically. And what's really impressive about it, and an important part of the story, is the emissions per vehicle mile. This is a graph. So, we talk about diesel. We have basically gasoline engines, diesel engines. Now, diesel engines, we tend to think of them as those, vehicles belching black smoke out the back. And that used to be the case, and for very old diesel engines, that's still the case. But for the new diesel engines, they're dramatically cleaner. But what's happened is they've been lagging behind the gasoline technology in terms of emissions, say 10 years or so. And they're starting to catch up. But this graph just shows that the particulate matter, went in 1994 from being, more than 0.1, where it's going to be 0.01, where the nitrogen oxides went from 5 down to 0.2. So these are 95, 99% reductions in the two key pollutants. And that's really dramatic, and that's very impressive. And on the gasoline side, looking at it a little different. So in gasoline, we've had the same kind of reductions. We've already had those same reductions. And what's really impressive about the gasoline vehicle story, the car story, is that the cost of reducing those emissions has actually gone down. Even the total per gram has certainly gone down. But even total per vehicle has gone down. We spent more on emission control in our cars 20 years ago than we do now, even though our cars are dramatically cleaner now than they were. And so this, the numbers are not it's hard to get good numbers because, for a variety of reasons, mostly that no one's actually ever tried to count it, but also because the car companies don't look at it that way and aren't going to give you the numbers even if they did. But anyway, it shows that it was about $1,000. We were paying about $1,000 per vehicle. This is real dollars in the early 80s, in the 80s. And then it dropped down to about $800 a few years ago. It's starting to climb up a little bit, but not very much. And so I mention this because the improvement in air pollution has come about almost totally through technology. When the air pollution laws were put in place in 1970, it was expected that some of the reduction would come through technology and some of it would come through behavior changes, getting people to drive less or to use transit. And they had a whole variety of what's become known as travel demand management or transportation control measures. But it didn't work out that way. It worked out, it was almost all technology. Now, the energy story is much more problematic. Looking first on the technology side, well, looking first just at the trends. This is a bar chart. It shows that what the changes were in cars between 1981 and 2003. Now, the fuel economy of vehicles in that time period basically stayed the same. About 20, 21, depending on how you measure it, 20, 21, 22 miles per gallon. That's what it was in the early 80s. That's what it is now. So, the story would be, oh my God, can't we do better than? I mean, why haven't we done anything? And in fact, what's happened, though, is that there's been tremendous innovation, technology improvements in making the vehicles more efficient in a technical sense. The innovation by the automotive industry, by the automotive engineers, has been very impressive. But what happened is, during that time period, is the vehicle of 1981 is not the same as the vehicle of 2003. The vehicle of 2003, of now, is much more powerful. It used to be that to go 0 to 60, that's a metric that's used to, for acceleration. It used to be a car, the average for all cars in the early 80s was 14 seconds to go 0 to 60. You can imagine what it is now. It's less than 10 seconds. I mean, that's a dramatic change in performance. It's less than 10 seconds. There are some, I saw the recent Corvette is 3.7 seconds, 0 to 60. I mean, this was unheard of, 20 years ago. Forget those muscle cars and all that stuff. This was unheard of 20 years ago, the kind of performance. So they're much faster, more powerful. I mean, not that, we're driving so fast or need all that power. My little editorial comment there. But got all the power and got a lot more size. The vehicles, we've got all the SUVs and the light trucks. So we got the bigger vehicles and they're heavier. So what's really, what's the remarkable part of the story is that there's been tremendous innovation in making the vehicles more efficient. The unfortunate part is that all of that innovation was used to make the vehicles, to allow the vehicles to be bigger and more powerful and heavier. So here's a case where public policy was not used to promote the public interest. It was allowed for private desires to be exercised. People wanted more power, and so public policy did not intervene, to support the public interest. And that's a theme I'm going to come back to. So if trends continue, vehicles get bigger and more powerful, but we'll put a fuel cell in it, and we'll use lightweight materials, and so it'll still get 25 miles per gallon, but be twice as big. I'm just joking. But in fact, the trends are starting to change now with the higher gasoline prices. So, so if you look at it strategically, what are the ways of reducing greenhouse gas emissions, energy use, and yet still, maintaining or even improving accessibility? And, the typical, the three broad strategies are you can reduce vehicle travel, but I haven't seen very many politicians out there advocating anything of that nature. So, one of the things I'm going to talk about at the end of this talk is how we can use information technologies actually to provide better, cheaper services that actually do provide more accessibility with a much smaller footprint, ecological energy footprint. And I think there are ways of doing that. Another is to improve the conventional technology, and I put hybrids in this category. The car companies go crazy when I say hybrids are conventional technology, or at least the American car companies do. Japanese car companies don't mind when I say that. But we have the hybrid technology and there's a lot of other efficiency improvements that are being brought into vehicles to make them more energy efficient. And then we can go to really, the big jump is to low carbon fuels and very advanced vehicle technology. And in fact, that third category is where we have to be. There's no question about it. There's no way we're going to reduce, oil consumption, because oil is finite. It's a lot of, we can get into, if anyone wants to talk about the peaking issue, but, the conventional, the informed conventional wisdom now is that oil is going to peak somewhere, and oil production somewhere in the next 5 to 15 years or so, maybe 5 to next 20 years. It's going to peak, and then we're going to see even more problems. And, with China and India and other countries increasing their consumption, something's got to give there. Just like on travel, something's got to give. We can't keep not building roads and traveling more. On oil, we can't keep consuming more oil because, there isn't the oil out there, at least the conventional oil. And with greenhouse gases, if we think there's even any credence to, the science of climate change, we really need to be doing something fairly dramatic in the next, starting to do something in the next 10 or 20 years to be able to actually be able to stabilize those CO2 levels at a level that's not, too threatening to society. Okay, so green technology is part of it. And part of it is, in a bigger sense, we've got to create a more of an innovation culture in transportation. And listening to who you all work with and from, most of you seem to be connected with the transportation community, if you can use that expression. The transportation community is probably one of the more conservative communities in our society for a variety of reasons. The transportation, if you think about it, but there are a lot of reasons that explain it. The transportation sector is a hugely complex enterprise. We have this mix of public and private entities. We have we have important public service functions that we impose on transportation in terms of providing, poor and elderly having access to a minimal level of transportation. We have the slow turnover of vehicles. We have the long life of the infrastructure. And so change happens very slowly. And yet here I am saying we really can't go on, certainly forever, and probably not a whole lot longer, in this way of just having this very slow incremental change. We're going to need some major changes fairly soon. And, I serve, one of the joys of my career is somehow I got into the situation where I serve on a lot of National Academy committees in Washington that come together on big topics. And a lot of them I've served with the National Academy of Engineering, where they bring in like senior VPs that head up R&D for major companies, for everything from the Exxons to the DuPonts and a lot of these other companies. And what's really impressed me about this group of people is that they have a sense of technology optimism that dwarfs anything that we talk about in kind of the public arena. They say, you give us some money, the resources, tell us the problem, we'll solve that problem. We might not solve it exactly the way we think we're going to, or the way you might want it to be. Someone might believe it'll play out, but we're going to make huge progress. It's a belief that humans have tremendous creativity, tremendous potential, and the record really bears them out. I've become convinced of it. So this slide here, I got this actually from a professor at University of Washington that dealt with genetic engineering. And that little sliver on the right, that's what corn used to be, many, many, many centuries ago. But this is what humans have done. This is without any genetic engineering or science. This is just over many centuries of being focused on creating a better food product out of this, and that's what's happened. And so it's just kind of and now with genetic engineering and all the bioengineering, just imagine how much more rapid these kinds of changes can happen and will happen. Yes, I know there's all these unintended consequences and so on to all of you out there, but we can get to that also if you want. So on the energy side, there's basically three options we have for transportation. One is we can use the biomass plant matter to make into fuels. That's what George Bush put a big pitch in for the other night. We do make a lot of ethanol now from corn, which is, in my mind, bad energy policy. It might be good agricultural policy. I'm not sure about that. I'm not an expert in agriculture. But it's bad energy policy. Basically, you gain very little in terms of fossil, replacing the fossil fuel. The amount of fossil fuel goes in is almost as much as the energy that you get out. The greenhouse gases are just a little better with ethanol than gasoline. And you have all the other environmental problems. And it's expensive. But anyway, but there are ways of using cellulosic matter, woody materials, switchgrass, which just means all kinds of grasses. Switchgrass is just stuff that grows real high and real fast and is a native to the U.S. Electricity. We had an experiment with battery electric vehicles in the 90s. And I'll show a good slide on that. It didn't really work out, but they're going to be back. And plug-in hybrids, that's the big topic now in the policy circle. That's a hybrid vehicle that has a bigger battery so you can plug it in so it gets most of its energy from the plug instead of from the gasoline, which is how all the hybrids are today. And then moving to hydrogen fuels from renewables and fossil energy. So I'll talk about these just a little, but this is a graph or a table that just shows that we really can get dramatic reductions in greenhouse gases with these different fuels and technologies. And so, if you have hydrogen made from water, we use solar power to split the water molecule and put it in a fuel cell, you basically get rid of all the CO2, all of the greenhouse gases. If you make ethanol from cellulose, from switchgrass or wood or trees or so on, you get somewhere, it depends how you do it, but you get 40, 90% reduction, a very major reduction. And then others, the hybrid vehicles, you get about 1/3 reduction if it's a good hybrid. There's different types of hybrids. I'll talk about that in a moment, too. And then BEV is battery electric vehicles. If there's any questions, just kind of explain it. If something's not clear, raise your hand. I can do that. We'll leave the profound questions for the end. Okay, so biofuels are part, actually I wasn't going to talk much about this, but George Bush made such a big deal about it, I thought, okay, I'll put a couple slides in. So we make a lot of ethanol in the U.S. from corn now, a huge amount. About 1/3 of all our gasoline now in the U.S. has ethanol. It has 10% ethanol in it, and it's increasing. And then you can make it from all these waste materials and woody material, grasses, and then there's biodiesel. I'm not so excited about biodiesel. The biodiesel lobby gets very upset at me, but basically, if you use waste materials, I could smell the frying oil as I came in the door here. If you use some of that oil and convert it, that's waste oil. That's a great idea. That's good. But once you go past waste oils, and waste oils are just a trivial amount compared. Remember I said 10, 12 million barrels per day of oil? I mean, think about that. And then think about, collecting all the oil from the McDonald's and Kentucky Fried Chickens. And, trust me, you're not going to get anywhere near that. A tiny, tiny fraction. So it's kind of trivial. So then once you go into plants that you have oil seeds, soybean oil and so on, it starts becoming quite expensive. And so, there's a potential there, if we as a society decide that's where we want to go, but it is expensive and there's land issues. So Brazil has been doing ethanol a long time, just like the United States, but everyone holds up Brazil. In fact, all the media the day after the Bush speech State of the Union speech was talking about how Brazil is already doing this and what a model it is. But in fact, the U.S. has caught up with Brazil in terms of the amount of ethanol and is probably going to be exceeding, and may even already be exceeding it in terms of production. They have a smaller market, but the total amount in the U.S. is going up. And it's going up because for two reasons. One is three reasons. Okay, there's subsidies to the farmers to grow corn, but I won't get into that. But then there's a subsidy for making ethanol from corn. It's 51 cents a gallon. And there's a mandate to use ethanol in areas that have air pollution problems, to put it in the oil companies have to use it or something similar, but that's the best option they have. So it's like, what kind of public policy is there where you not only provide a subsidy but a mandate as well? And that kind of gives you pause that, maybe there's something wrong here. It does for me anyway. So anyway, but biomass, it's a good option. We can get maybe 5, here, estimate I do about, if we can get up to about 30% of our fuel maybe being replaced by biofuel if we got really aggressive. That would take up about 5 to 10% of all the land. Not a trivial amount, but it's possible.
Is that all land or is that all farmland?
This is all land. I do have if you're interested, I have a slide on for exactly how much of the farmland that would be. Because it's not just farmland, we're talking about forested land here as well that could be used. So what I believe, and I think it's increasingly becoming accepted in the automotive industry, is that we are going to move away from combustion engines. Al Gore said that in his 1992 book, Earth in the Balance. He was ridiculed for it at the time. I guess you might say he was ahead of his time. I don't know. But it is going to happen eventually, and the auto industry already is electrifying our vehicles. They like electricity in the vehicle because, all those motors and computers and everything, they run on electricity. So they want to figure out some way of converting a vehicle into electricity. So it's going to happen. The pathway, this is actually a slide from General Motors. They say, well, we're going to go from internal combustion engines to hybrid to fuel cell vehicles. And the reason they put it on that trajectory is because a fuel cell vehicle actually is an electric vehicle. It's all electric. It gets the electricity from hydrogen. And what a fuel cell does is it converts hydrogen into electricity so that you have your electric vehicle. A battery electric vehicle, it gets the electricity from a plug, puts it in a battery, and then uses it. So anyway, so the battery electric vehicle experiment, as I mentioned before, failed. In some ways failed. But in fact, it led to a tremendous investment in development of better batteries, better electric drivetrains that are now being used in the hybrid vehicles. The Toyota Prius, all that electric drive technology in the Prius comes from all of their work on battery electrics that they did in the 1990s. And the same with Ford and all the other companies doing it. The problem is batteries are still big and expensive, and kind of a electric vehicle that runs on just a normal vehicle is probably never going to be running on electricity from battery, but there's going to be lots of opportunities. Part of the vision I have of the future is we're going to specialize our vehicles more. I sometimes refer to that as the sneakerization of transportation. That we used to, we all, some of us with gray hair grew up, we only had one pair of tennis shoes, sneakers, for everything. Now you have 10 pair, running, walking, tennis, dancing, And so the same kind of phenomena is likely to happen with transportation, with vehicles. And then there'll be a real role for battery electric vehicles. Okay, I should move along quickly. I could go on forever. That's the trouble when you get someone that's too excited about their topic. So there's diesel vehicles, diesels. They're very popular in Europe, not here, not likely to be, I don't think, anywhere near like in Europe. Half of all the cars now in Europe run on diesel engines. They've been mostly kept out of the U.S. by air pollution rules, but also by high diesel fuel prices. Hybrids, that's the thing everyone gets all excited about. These are all every car company is talking about bringing out new hybrid cars, and this just shows all the proliferation of models that are going to come out. But if you look at the numbers, there's still more diesel, light-duty diesel vehicles than hybrids. The hybrid number is increasing a lot. Toyota I think is up to about 200,000. In 2005, I think they sold close to 200,000 hybrid vehicles. About 2/3 of them Priuses, the rest Highlanders and SUVs. And other companies are starting to build them. So that's changing, but it's unclear how far, how fast. Now, the whole idea, let me talk about hybrids, because that's kind of something, at least in where I live, it's a big topic. I don't know how many people have hybrid vehicles here? Okay. Now, if I did this in Davis or Berkeley, it probably would be almost half to give you a sense of what's happened, in certain regions. The idea here is that with hybrids, that you can make a vehicle much more efficient. You're basically putting an electric motor in, combining it with a combustion engine. It lets you to capture the energy, makes sure the engine's smaller. But the problem is it's more complex and more expensive. And right now, the diesel cars are about $3,500 extra compared to a comparable gasoline car. It's going to come down. They're shooting for $1,500 to $2,000 premium. You'll get much better fuel economy, but there's still a question, are people willing to pay more even though they're getting fuel economy? And that's a good market research question. I do have an answer for it, by the way.
Question too?
Yeah?
You also get a tax break by the government, too, by having one.
Yes. In fact, there used to be a small one, and then the new law starting in 2006. It's very prejudiced against the Japanese companies, though. They say only the first 60,000 cars sold by a company gets a tax break. So for Toyota, in 2 months, if you don't get it in the first 2 months, forget about it, 2 or 3 months. If you do it for GM, you probably have it for 5 years. Maybe forever. Okay, so we've been doing, my program at Davis, we've been doing a lot of market research on vehicles, and the question is, why all of a sudden are these hybrid vehicles so popular? What's really going on here? The hypothesis we're working with is that, I'll test it out here, see how many of you agree with this hypothesis. The hypothesis is that we as human beings, most of us really want to do the right thing, do good things. We're not willing to pay very much for it, but we do want to do good things. But in vehicles, you look back in time, have we ever had the opportunity to make, choose the right vehicle, an environmental vehicle? We switch from leaded to unleaded all at once. No choice there. Emissions for all the vehicles are about the same. If you look in any category of vehicles, the fuel economy is about the same. So unless you're willing to make a compromise in terms of getting a smaller vehicle, basically you've never been able to make that choice. So hybrid vehicles, for the first time, they present a technology, a vehicle, in which people feel like they don't have to compromise, and yet they can get a technology of the future, something that's good for the earth, and something that makes them feel good, and you get better fuel economy and lower emissions. You pay a little more, but you get all those things. And so for the first time, people are able to exercise this desire, to do the right thing, to do good. And of course, one of the questions is how many of us really, think that way, and how much are we willing to pay, extra to get to feel good? And that's still unresolved. Okay, and then there's hydrogen. Let me just go over that very quickly. This is one of those transformational options, the hydrogen economy. We've been hearing it for a long time. But what's making it more real is the fuel cell. And a fuel cell is this device that converts hydrogen into electricity and does it very efficiently. So therefore, now you have a way of taking advantage of hydrogen, and you have a vehicle or technology that's very efficient, zero emissions, and it can use and hydrogen can be made from all kinds of things, renewable and without pollution or anything. So the vision is very compelling. So it can be made from many things. The big question is, where is it going to come from? We'd love it to be from renewable, but if you make it from fossil energy, from coal, it's cheaper, at least right now. So you're not gaining anything if you make it from coal, unless you take the carbon dioxide or carbon that's emitted, when you convert the coal into hydrogen and capture it and sequester it. And it kind of sounds a little troubling to some people, I know. But it actually can be done technically and economically. It's not that difficult to do. So it is actually one of the favored strategies. I don't want to, in some of your minds, I don't want to demean it by saying it is one of the favored strategies of the Bush administration. But it also is important in China and a lot of other places. The question is, how are we going to think of CO2? We can take it, we can put it in the ground, we can secure it there, and it'll stay there, almost all of it, almost forever. But I do use that word almost, and so the question is, will carbon dioxide be seen as like nuclear waste is now? If it's not, if carbon dioxide is seen as, okay, a little leakage is okay, let's do it, then we as a society can do it fairly cheaply and fairly efficiently and at pretty large volume. But if people start saying, this is not such a good idea, it's going to leak, this kind of stuff, then just like the NIMBYism, the result is costs go way up, and then it becomes not a very good option anymore. Anyway, so hydrogen's not going to come around for a long time. This is the GM car. It's a very sleek design, and this is kind of transformational for vehicles, at least, in that you can put it into the whole fuel cell system. You can put it right into the chassis of the vehicle, like a 6-inch or so deep, and then you can put any kind of car you want on it. You can design it any way you want. So, all the designs of cars can change dramatically. We don't have to worry about where the drivetrain is or where the gas tank is or the radiator and all that steering wheel and all that kind of stuff. So it opens up the whole design envelope. But you know what? There's a few slides here I want to get to that I know some of you will be more interested. You see, I've got a little, here's a fuel cell wheelchair, a fuel cell robot, fuel cell scooter, fuel cell submarine. So, just to give you a sense that, there is a lot of investment going into it. There's a lot of, and there's my governor sitting there signing the Hydrogen Highway Executive Order at UC Davis. There's me on the side. Okay, moving right along. We can talk about, if you want to talk about politics and policy, California has the greenhouse gas law for vehicles. Oregon is in the process of adopting that same law as well that reduces greenhouse gases by 30%. We can talk about that. There's a zero-emission vehicle rule in California. Talk about that. But here, the last topic I want to cover is this more fundamental transportation challenge. And that is, in some ways, we're developing a land use pattern that's too dense for cars, not dense enough for conventional transit. We have this very diffuse transportation system, a lot of stakeholders, a mixed system of public and private. And we've created this monoculture. And when I say a monoculture, what I mean by that is, first of all, cars dominate. Almost all travel, urban and even much of the interurban is by cars. All vehicles serve all purposes. All roads serve all vehicles. Almost all roads and all parking is free. Almost all vehicles use petroleum fuel. We've created a transportation monoculture. And it's very difficult to introduce change, new species, into this monoculture. So just some ideas of how we can change it, and this is using information. So we've tried travel demand management. Many of you, I gathered from your jobs, have dealt with this in one way or the other, and it's largely failed. I hate to say. I'll say I've worked with alternative fuels for 20 years, and that's largely failed. So, it's like we have to deal with failure sometimes. It's not clear that it has, it's certain, transit-oriented development, the new urbanism, all of these are coming along that provide new images and new ways of thinking about it that seem to be, getting some acceptance in some places, in Portland, for instance. But, yes?
What's paratransit? Do you come in from a plane?
From a play?
To drop in from a plane.
Oh, plane. No. Okay, so I'll answer that. So what I'm suggesting is that we need more than just, incremental change at the edge. And we can use information technologies, I think, is one way, and maybe the best way, of really transforming our transportation system. We have ITS in transportation, but it's really only been used to make very minor changes. We manage our roads just a little bit better. But it's really, if you look at what effect ITS has or is likely to have the way it's being done, it's really a very tiny change in terms of the performance of our transportation system or the capacity of our transportation system. We need something much bigger, but information technologies does provide an opportunity. So it can be applied, for instance, to car sharing, and that's the idea. There's car sharing is in Portland here. How many know what car sharing is? Okay, so I know what car sharing is. So car sharing, where you have access to these vehicles, you only pay for it when you use it. And, if you think about it, the average cost of owning and operating a vehicle is $7,000 per year, per car. That's the average. Now, one way of thinking about it is, can we provide you that same level of service for that amount of money or less? And I think the answer is yes. But information technologies are the key to it. So with, right now with cars, we have our own car, and we don't even think about using another mode. In Portland here, you do a little, okay, downtown, a little bit. But most people, you wake up in the morning, you don't say, okay, how am I going to get to where I'm going? You just walk out and get in your car. You don't think about the transit alternatives and so on. And the reason for that is that, it's hard to provide those services, kind of the land use patterns we have and so on. So car sharing provides one way of doing that, so that, part of the reason we buy a car and depend on it is that for those occasional times when we make a long trip or we're going somewhere where transit wouldn't work, we're not willing, we want to have that car, and so we just become committed to the vehicle we have. It's a sunk cost. So car sharing is one way, one piece of it that with smart car sharing, where it's easy to access it and billing and so on. Smart paratransit. Okay, so paratransit mean, para is of or related to, kind of you go back to Latin. So it's sort of transit. And in this case, jitneys or the elderly and handicapped services that they have. Jitneys exist around the world in different forms, or paratransit in different ways. Smart paratransit. So if you could just call up, if I could just punch in here and say I needed a ride, to the other side of town in 15 minutes, and I walked out and that vehicle showed up, that would be pretty convenient. In fact, that would, in many ways, be a better service. I don't have to worry about parking and so on. So smart paratransit, so these would be vans. It used to be called dial-a-ride back in the 70s. This is upgrading it with modern technology. Dynamic ride sharing, and that's kind of, this is computerizing ride sharing. In the Bay Area and San Francisco area, we have casual carpooling where people line up at certain places to get picked up, and cars line up, people line up, and they, it's really hitchhiking, but in an organized way. But it works because there's one destination. They're all going into the financial district in San Francisco. But if people had more information and you had some way of security clearing people, at university, you have bulletin boards of people getting rides, computerize that. There are these services that are just getting started. There was an article in the Wall Street Journal about this a few days ago. So that's dynamic ride sharing. Neighborhood cars, we don't need the big SUV to go down to the corner, but we get the big SUV for that once a year trip up into the mountains to go skiing or so on. But if we have access to these other services, car sharing and so on, then we don't need it. We can maybe have a little neighborhood car just for around town, and then which is much more energy efficient, smaller footprint. Vehicle to grid, we can take our vehicles with electric drive, we can plug them into our house, and we get extra utility out of that. Bus rapid transit, personal rapid transit. Anyway, all of these are options that we're barely considering in the transportation system, and information technologies make them possible. They do have to be combined with some kind of pricing innovations. We do have to bring more pricing into the transportation sector and better land management. But that's the kind of the basic vision that I would throw out about how to transform the transportation system in terms of modes of service. And it really comes down to that $7,000 per vehicle per year. I mean, if you think about it, we've got to be able to provide that quality of service. I think some people will want service that's cheaper, a degraded level of service, but where they pay less. But others we can provide a higher quality of service, for the same amount probably. Okay, so I got two slides here to end it up. So conclusions is just summarizing what I said. Almost all the trends are going in the wrong direction for transportation. How's that for a cheery thought? We are going to have to make major changes. Innovation is likely to accelerate. We do need to create more of an innovation culture, especially in transportation. We've got to figure out how to do it. We've got to think about it in terms of this monoculture. Information technologies, I think, are an important key to it. And those of you that are researchers, this is all good news. Researchers thrive on bad news, right? On uncertainty and bad news. So we've got bright careers ahead of us, all of you that are students especially. But from a larger societal perspective, there is a lot of knowledge being generated. The challenge is how to bring this research and science to bear in terms of how decisions are made and investments are made. And so let me just end on a philosophical note. One of the questions is, why aren't things happening? And I think we're all struggling for some framework to understand that. And the way I think about it is that, we as individuals, when we make choices, left to our own, we want a bigger house, we want a bigger car, we want a bigger yard. Not all of us, not all of the time, but mostly. But doing all those things, moving more, bigger things, consuming more, has these implications for society. It doesn't work for society. So the role of government is to somehow intervene and say, okay, there's this spectrum of behaviors, and we have the private desires, and we have the public good, and somehow we have to reconcile these. And how it's reconciled in different societies is it's reconciled differently in different societies. If we, in the U.S. society where we value individualism, consumer sovereignty, we have this history of open space, a lot of resources, big frontier, where we've been isolated from the world, in terms of conflicts for the most part. We tend to come down on the side of the private desires, allowing market forces to make the choices. But you go to other societies, you go to some of the Asian societies where there's more of a collectivism, collective values, or if you go to Europe where there's been more limited land and resources, more of a vulnerability to foreign conflict, which is relevant for the oil and climate change issues. Europe is engaged on it much more, and I think that's a big part of it, because of their history and how vulnerable they feel. And so, that's kind of one way of thinking about what's happened. Now, we have to understand and accept that, that the United States does have a certain culture, political culture, and so on. But yet, we have to understand there is a public good at stake here, and we all are part of it. And so, how do we create policy instruments and strategies that will protect the public good and still be responsive to what we as individuals want? And so here I am in a university, so I end it with this slide, and the academics in the audience will appreciate this. Thank you. So I talked way too long.
No, you're fine. But before we launch into questions, I do want to make sure that we thank the Oregon Department of Transportation, ODOT, who is sponsoring our Visiting Scholar Series and helped bring Dan here to campus. So I want to thank ODOT for that support. And now we can Open up the question.
Yes.
I believe you about the technological improvements, but how do you get the public sector to improve? Many of the things that you've been talking about, say commercial shared ride paratransit or other activities like that, are illegal in most cities.
And that's right, and that's a real I mean, you know, the reason we don't have those paratransits, you know, I know in Sacramento, they've developed the paratransit operation there. It serves the elderly and handicapped, and the bus system, you know, pays them to do that. But they've developed all of this automated vehicle location, and all they can do smart paratransit, and they're not allowed to. And, you know, because the regional transit district, the bus operator, says that's our job. And basically it's a monopoly, and I think that's what, and you know, you get in taxis and so on. Yeah, that's a huge, huge challenge. But I think that, and it's going to be slow to change it. But I think once it's understood that there are these opportunities, that to create a better transportation system that people will want, that provides better service, and especially as us baby boomers, I think one of the keys to this is us baby boomers, you know, my generation, as we get older and get into retirement, we're going to become a natural constituency for these other kinds of services where, you know, we don't see so well at night and we don't want to drive and get decrepit and, you know, bent over and so on. There's going to be more of a demand for doing it differently. So that's one little hope for the future. But yes, I agree. I don't have all of the answers. I just have the strategy. Yes?
My impression of the fuel cell technology is that it depends pretty heavily right now on fossil fuels to get that hydrogen recharged.
Microphone, sorry.
I think I am using the microphone.
Okay.
Thank you.
You have to hold, sorry.
I have a neighbor. Yeah.
Teamwork.
Is that going to continue to, am I correct, and is that going to continue to be the case in a...
Okay, well, there's the fuel cell and there's the hydrogen. The fuel cell is the technology that takes any fuel and converts it to electricity. So the question is really the hydrogen. How is the hydrogen made? And right now, there's actually a fairly large hydrogen industry for petrochemicals and so on. And it's all made from natural gas and petroleum. If you go large scale, it is much easier. We know how to make it from coal at a pretty competitive cost. And, you know, DOE, Department of Energy, is putting money into it. And that's kind of the issue I was referring to, is that the easiest, cheapest way to make hydrogen in the near term is to make it from fossil energy, from coal especially. Clearly, you know, one of the problems with that is the CO2 sequestration issue. Well, first of all, there has to be a rule or law or an incentive not to just emit the CO2, and then the second part is how to sequester it. So that's all doable, but, you know, there's a lot of questions about it. We'd like to go to renewables, and the reality is it's expensive, but, you know, this goes back to that little ear of corn slide I showed. I mean, this is an example where we've put almost no resources into renewable energy. You know, the investment, you know, is just trivial that the world has put into developing advanced renewable energy technologies. You know, there's been some success with wind energy, which has been moderately successful, but solar technologies, you know, it's really a trivial amount of effort. And so, like this group of, like I served on the hydrogen, you know, one of the committees I served on was the Hydrogen National Academy Committee. And there was a guy, a vice president, senior VP of ExxonMobil, responsible for R&D and a lot of other stuff. He said, I mean, this was clearly his position. He said, look, we need to use the sun eventually. He says, we need to put resources in there. There's no reason why we can't make hydrogen with solar technologies and do it at a reasonable cost and efficiently. But it's going to take time, it's going to take resources, and we've got to be committed to doing it. And, you know, that's not happened neither on the private side nor the public side.
What's your view of role of nuclear?
Nuclear?
Nuclear, yeah, as a bridge technology, or as, I mean, because one of the stories of hydrogen highways is this could be a nuclear highway.
Well, I'm a child of the 60s, where nuclear was evil. But I'm open-minded about it now, I guess. I'm skeptical. There's the proliferation problems, there's the waste problems. But, it's kind of looking in the future. It's pretty daunting what we need to do. And it's not just the U.S., it's the world. And the question is, can it be done safely and securely? And there's a lot of effort being, I think I'm willing, at least for me, I'm not an expert in that at all. I listen to a lot of people. I'm willing to be open-minded to it. But it's still, right now, it's very expensive. So even if, like the federal government is, the last energy bill poured out huge amounts of subsidies and incentives for nuclear, but it's not clear even that's going to make it work because it is still so expensive.
I want to explore the biodiesel issue a little more. Washington State has just either passed or is about to pass biofuel legislation. Oh, thank you. Oregon State tried to last session, and will probably there'll be another biofuels bill this session. And from ODOT's point of view, is in terms of thinking about alternative fuels and which ones are more viable than others. You said it's more expensive, but if oil becomes $200 a barrel, is that then a viable alternative? So is it something that's worth thinking about, even though it won't completely replace all the diesel use we currently have?
Okay, a few thoughts. One is biodiesel to me is an example of what I said earlier, that we want to do good things, many of us, and there's so few opportunities in the transportation sector to do it. And so you see a lot of local grassroots groups, really getting enthusiastic about biodiesel because, you can take the cooking oils and convert it into fuel, and it just sounds wonderful, and it is. But as I said earlier, there's a limited amount of it. And so if you can figure out a way to use these waste oils and focus on that, that's clearly a good thing to do, almost any level. And there's enough public subsidy incentive to make it worthwhile, to anyone. But it's a problem that, so the other part is, I don't think the oil prices are ever going to be above $100 a barrel on a sustained basis. The one thing I didn't talk about is that if we, that graph on CO2, business as usual, part of what's implied there is that there's huge amounts of fossil energy in the world. There's huge amounts of coal. There's huge amounts of tar sands in Canada. This tar sands in Canada, it's a tar-like stuff, but it's got all of this hydrocarbon in it. There's as much energy in those tar sands in Canada as roughly all in the whole Middle East. But the bad news, so the business as usual case is we're going to move, when conventional oil peaks, which is pretty soon, we're just going to start, the oil companies are just going to start making oil out of this so-called unconventional oil, the heavy oil, tar-like stuff, coal. There's huge amounts of that in the world. And they'll do that, if there's no reason not to, because that's the cheapest way and easiest way for them to provide gasoline. There's there's actually a few important downsides. The most important one is that every gallon of gasoline made, like from tar sands, emits about 50% more greenhouse gases, more CO2, than gasoline made from conventional oil. And the same with these heavy oils and others. So actually, this is already happening. Tar sands, they're already making 1 million barrels a day of oil in Canada, of petroleum from tar sands. And they're projected to go up to 5 million, is what they're planning. But, that's what's going to happen. And that's why that's the business as usual case. And if we, as I said, CO2 is going to increase even if we don't do that. And if we start, as I say, recarbonizing our energy system, it's going to be a disaster. And so, that's a long answer to come back to you. So for that reason, though, you can make all of oil out of all those things for much less than $100 a barrel. You can do it the tar sands are doing it for $20 a barrel. You can do it $30, $40, $50 a barrel easily. And so there's no reason to think that oil is ever going to be above $100 a barrel on a sustained basis, and probably never, not even much above where it is now on a sustained basis, unless we say CO2 is a problem and, make them pay extra for it or something. So yes, I'm of two minds with this biodiesel thing. I like to say, because I believe renewable energy is the future, and we need to focus on it and some of these biofuels, but on the other hand, the technologies and the options are really not here to do it well. And so I guess, this is where experts and leaders come apart. The expert in me says, let's do it right. The leader in me says, you got to do something. You've got to start down this path. And so, yes, it's going to be more expensive, and yes, there's problems. But as long as you go in it with your eyes open, that you don't, and that ODOT or the state doesn't think that this is going to be cheap, it's good. Oh, wait, anyone else? You are. No. Yeah.
I really like the aggregate chart of miles traveled per person per year. I guess that's a French study, and certainly I guess that would be true for large continents. Is there an island effect, or are there some early indicators of some different patterns? So, for example, Japan is an island, which I think has quite a different travel pattern than the U.S. for sure, China probably, Europe for sure. And if, your projection of urban densities. I mean, are there some examples where the travel isn't going up exponentially like that in any urban areas, or?
I don't think so. In those, but it is different. It happens in different ways. There's the Singapore story where they use a lot of pricing and provide good transit. The Japanese story is, given that it's a small area with a lot of people, they have invested in transit technology. So Japan is an outlier in the world. For major industrialized countries, it's an outlier in terms of how much transit. But I believe even in Japan, I think it's still over 60% of passenger travel is by car. So even in that kind of most ideal of circumstances, they still depend on the cars, and the car use is increasing there. In Western Europe, it's especially increasing. Most of us go to Western Europe. We go to Paris or London and use the metro and so on, but that's not Europe. Even in Europe now, about 80% of passenger travel is by car, about 15% by transit, a few percent by air. Cars, they've taken over. What can I say? It's an expression of the desire for personal mobility and all the benefits that come from personal mobility. And, part of the challenge is how do you meet that desire? Because you can't legislate, in most of our societies, you can't legislate people, out of their cars. It's not going to work. Certainly not going to work in the ballot box. And so, and that's why I come back to these information technology options. How do we provide at least as good or even better service to people? We have our cars, but it's not like that's the ideal situation. Do we really want to take care of these cars and all the problems and registering insurance? Do we really want to have just that car? Why not? Someday we want to have a sports car. Someday we might want to have a pickup truck to go pick something up. Someday we do want the big SUV, and yet we're locked into it. So if we actually have a transportation system where there's more choice, and this kind of comes right back to the American mantra of choice. And I think this plays into it. So I think there's hope, but it's going to take a lot of leadership and innovation and, change. As the gentleman in the back talked about, there's all kinds of forces working against it. Yeah?
If we have carbon sequestration subsidies or offsets against carbon taxes, are there any kind of large-scale technologies that are out there that are likely to happen?
Well, the ones I know about is for transportation fuel. And it's already, okay, you can sequester it. They've sequestered CO2 for a long time because the oil industry has done it, like in Texas and Oklahoma, for a long time just to help them get the oil out there for enhanced oil recovery. And so they know where they can put it, and they pretty much know how to seal it and so on. And in Norway, they've been burying the CO2. Norway had a tax on CO2. And so they were actually, in the North Sea, they were actually burying it. They have been for quite a few years. And with coal, when you gasify coal, it's very easy to capture the carbon dioxide. And that's why I said there are certain processes that are very amenable to it, both for the capture part of it and then for the sequestration. The sequestration question is which places are really secure. You know, in the U.S., our land is has all of these wells all over the place. You know, we have something like 3/4 of all the wells in the world are in the U.S. We've perforated our land with wells, you know, for oil production. So it's not clear how many of these areas really are sealed down there. But there's a lot of research now going into geologically looking at it. So it's, but the problem is, you know, one of the challenges with CO2 is the volume of CO2 is much greater. You know, the carbon comes out and combusts with the hydrogen, with the oxygen, and so the quantity is like 3 times greater, you know, than you know, for each gallon of fuel, you know, you get a quantity almost 3 times greater. So we're talking about a massive, massive logistical problem of moving that stuff around. So I don't think it's very viable for the entire energy system, but there's probably lots of opportunities in places where it could work quite well and fairly cheaply. And yes?
You had mentioned about renewable fuels, which was the kind of focus, you know, fuels from renewable resources. But you also mentioned about the exponential growth of transportation, much larger than the growth of population. And there are 2 aspects. One is the fuel to drive the vehicle, and the second is the lanes on which it will drive.
Right.
So the other aspect of the resource constraint, both from a mass transportation and from a private transportation, I've seen on the Discovery Channel, one is in New York, they are talking about a 200-meter metro, which is going to be 10 years from now. The entire metro, fairly upgraded metro with high-speed trains running much below underground than they run today. And on the private front, where you actually have vehicles running in corridors rather than concrete, you actually have corridors of transportation where vehicles are able to fly, which is again
able to fly, did you say?
In terms of, you know, they at a limited constraints, not as freely as an aircraft, but they actually can, you know,
Yeah.
So you have 5 cars flying on the road. I mean, the lowest one on the road, different heights. So are there any thoughts about such technologies and the lanes for the transportation?
Well, I'm a little skeptical about the flying part of it, but I imagine the traffic control issues involved in that. But there is that question, you know, the question that you raised is, you know, that I raised is, you know, how are we going to handle increasing? I mean, our population is increasing, and people are traveling more or want to travel more, and how do you accommodate that? And I think part of it is, you know, some of these kind of new mobility ideas, that's what I refer to it as, is that, you know, there are ways of getting people out of the single occupant vehicle. You know, the car sharing, the smart paratransit, and those also connect up with conventional transit. You know, because part of the time, reason we don't use transit is, you know, the last mile and the first mile. You know, how do you get there? And so these are solutions to that. So we can make the collective transport systems, conventional, more viable, and shift some of the travel that way. And then pricing on top of that. You know, using pricing so you know, move around the peak travel and both spatially and temporally. And, you know, it's like, how much travel do we really want to do or need to do? You know, one example I always use is, you know, what is the saturation for travel? And for me, if you told me I could get to Paris in 10 minutes and it would cost me $5, I'd be there for dinner, you know, probably every other night. Okay, so we already are, you know, this concept of latent demand, you know, doesn't make a lot of sense because there's all kinds of implicit assumptions. And we already are constrained in how we travel. And so it's more a matter of using pricing on the one hand and a bigger choice of services on the other to manage that transportation system. And in certain places we clearly need more roads, where there's a lot of more growth. But I think there's lots of opportunities to improve it without providing a lot of more road capacity. Yes?
I was wondering, it seems that part of the assumption is you talk about cars, people wanting to have more transportation, and people wanting to transport themselves more. And I wonder, you said Americans want choice, but it seems to me that a lot of places, not having a car is not a choice. I don't know that, a lot of us transport ourselves a lot because we have to get to work, or the supermarket is too far to walk, or all these things. So it seems like part of your assumption is that we want to transport ourselves more in that way, and it seems like there might be opportunities for us to create infrastructure so that we could walk to the market or things like that.
That's right. There's lots of opportunity for non-motorized travel, walking, biking, for using telecommunications for shopping as well as working and so on. And that's part of the picture, is providing more choice in that way. A lot of you in the room, Jennifer and others are working on transit-oriented developing and walking environments and so on. And I think that's an important part of it. There was in Sacramento, part of the question is how much change can you get that way? And people that did energy and air quality, part of the reason the whole travel demand thing never got a lot of traction, if I can use that word, is because they never saw that there were big benefits attainable in the near term. All the forecast, all the studies says, you get 0.2% for this and 0.3% for that. But, if you put it all together, I know Sacramento has put together this vision plan that's been very much of a populist-based process, and they're talking about a 25% reduction in VMT by 2050 with land use and transit and a lot of these ideas. So, it's part of moving away from this monoculture idea. It's moving away and thinking about, choice in choice in walking, choice in, having downtowns that really are livable places to be, that if we want to live in a dense area, that it works for us, at different stages of our life and so on. So it's part of the problem. That's why I don't know, maybe I overuse this concept of a monoculture, but it seems to me that's the core of the whole problem. And we need to diversify it somehow and get away from it. And there's all kinds of forces working against us. But, that's why we're professionals in this area, because we believe we can change it. Yes?
I've got two questions, actually. First, given what Bush said the other day and the kind of the movements in the oil industry, and with people like Governor Schwarzenegger interested in hydrogen and lower carbon fuels, I'm curious what your sense is of how many decades do you think it really is going to take at this point, given those trends, to move to I think what you're proposing is a fully low to no carbon based transportation infrastructure. And which is a massive infrastructure. So that's the first question. The second question is, even if that's the case in this country, what does that mean for developing countries? So you talked about these technologies being very complex, very expensive. Indonesia and India and many other places still use, and there's massive growth in these polluting three-stroke engines. Where do you see those countries going 20 years down the road if we have a low-carbon future?
Okay, well, it's going to take time. I think in a 20-year time frame, I can start to see some major changes happening in terms of fuel cells and electric vehicles being used widely, and fuel cells and so on. But because of slow turnover, that means, I can imagine in 20 years major changes happening, and in 50 years those showing up in sizable reductions in oil use and greenhouse gases and so on. But that's probably the optimistic scenario. And the rest of the part of it is the rest of the world. As I said, I do a lot of work with China, and one of the reasons I paid more attention to this coal and coal sequestration is because China has huge amounts of coal and not very much natural gas or petroleum. They're going to use that coal, and they're going to grow. And how are they? The question is, how are they going to use that coal? There's Sheikh Yamani, the oil minister from Saudi Arabia a couple decades ago, said, the Stone Age didn't end because we ran out of stones, and the petroleum age is not going to end because we ran out of petroleum. Still, having said that, with coal, China has so much coal and no other good option and it's so cheap that they're clearly going to use it. And so I think it's incumbent upon us to develop better ways of using that coal that are, more environmentally sensitive and so on, lower CO2, and to work with them. The U.S. government has had a mentality of, unilateralism in many of these things, and if you work for the U.S. government, you can barely travel abroad. I mean, actually, if you work for ODOT, I suspect, I know Caltrans in California, you can't cross the state borders. It's considered a boondoggle, or I don't know why they don't think that, but same thing. And the U.S. government is like that. But, this is a globalized world, and it's in our interest, it's in our economic interest, it's in our interest in so many ways to be working with a lot of these countries. And, China is in this area is the prime example of it. And all these things we talk about for the U.S., we can do them essentially just as fast, if not faster, in China. And, in fact, there is some possibility of leapfrogging some of the things that we do here, and for them to do it better. I mean, they're going to run in, the problem with the lane capacity problem is probably the one that and the air pollution problem is the one that's driving them, because, they have this dramatic expansion of vehicles, and they have these built-up dense cities already. What do you do? Beijing is complete. They built 6 ring roads, and they're completely congested. Shanghai, which is even more affluent than Beijing, has much fewer vehicles because they have discouraged vehicle ownership, is completely congested. But it's so dense, it's like, what are they going to do? And so that's really, and then their air pollution is so horrible that, it's really so bad they know they have to do something about that. So there are all these different forces at work, and every country and every region is different, and there's lots of complexities, and therefore lots of opportunity for researchers. Go back to that theme. I think we're finished, right?
I think on that note, we will have to finish. So I want to thank ODOT again for sponsoring today's speaker, and thank you, Dan, for joining us here.
Thank you.